Powerphase has developed an adaptive compressed air energy storage solution called FastLight. FastLight was envisioned as an upgrade for the existing Combustion Turbine (CT) facilities to bridge the gap to the low-carbon energy future by cutting existing CT facilities' heat rates by up to 50%. A FastLight facility utilizes overabundant renewables or off-peak low-cost energy to charge the storage facility. The FastLight adaptation can be applied to nearly every industrial CT installed today, transforming and repurposing them into flexible energy storage facilities. The FastLight solution leverages existing transmission and interconnects, as well as commercially available industrial-proven products, lowering the risk, cost, and lead time to deploy when compared to alternative energy storage solutions. The FastLight facility is comprised of modular low and high-pressure compression trains, optional fuel-driven compressors, compressed air storage, a heat-recovering recuperator, a cooling system for the site, and an upgraded combustion turbine, CT, to Powerphase's patented storage engine. The low-pressure compressors produce the equivalent CT compressor discharge pressure air. This attribute to Powerphase's FastLight design provides the flexibility to operate without stored compressed air, providing firm, peaking energy when demanded. The high-pressure compressor boosts the pressure from compressor discharge pressures to 1500 psi for a compact storage footprint capability. When underground storage is unavailable, Powerphase leverages a commercially available pressure vessel used today for transporting high-pressure fluids. They are packaged in such a way that reduces construction and installation time at site. After charging with the renewable or low-cost energy, the stored compressed air is discharged to the FastLight storage engine, where it first exchanges the heat of the storage engine exhaust to the compressed air in its recuperator, producing varying temperature airflows to supply the primary flow and secondary cooling flow for the hot gas path. The CT upgrade to a FastLight storage engine, simple and mechanically feasible on most industrial frame combustion turbines. Due to the hot gas path of storage engine being unchanged, its adaptation to low-carbon fuels remains feasible with OEM or aftermarket suppliers. Future hot gas path upgrades. When costly low-carbon fuels become widely deployed, the storage engine will only require approximately 50% to operate at the same power as a traditional CT. The FastLight facility has 3 primary modes of operation: storage, discharge, and continuous peaker mode, providing significant value and flexibility beyond the traditional CT and energy storage systems deployed today. The primary advantage of the FastLight storage engine is its ability to operate as a continuous peaking asset when storage is depleted, providing firm capacity. The fuel-driven compressors are optional additions to the facility to further increase the net peaking power available to deliver to the grid. Contact Powerphase today to learn more about FastLight energy storage solutions in support of your low-carbon initiatives.